Before we do a new lecture, let's see this example. This example says that x can choose 998. So you see x gets bigger and bigger, goes to positive infinity. If x goes to positive infinity, where does this one go? The negative 14 over x plus 2, where does this one go? If we let this one be y, where does y go when x goes to positive infinity? Okay, you plug in 8 here, and negative 14 over 8 plus 2 is negative 14 over 10, which is negative 1.4. When x is 98, you plug in here, negative 14 over 98 plus 2, which is negative 14 over 100. You will end up with negative 0.14. If x is 998, you plug in, you have x is you have a negative 14 over 998 plus 2, which is negative 14 over 1000, which is negative 0.014. You see, when x gets bigger and bigger, y equals this big quantity gets closer to 0. You see, more and more decimals. Yeah, that's the point I want to make. Okay, x goes to positive infinity, y, or this irrational expression will be going to 0, close to 0. Okay, so I will use this one in the following lecture. In this lecture, we will talk about find the oblique asymptote for the function and sketch the graph. The given function is f of x equals x squared minus x minus 20 over x plus 2. We want to find out oblique asymptote and graph this rational function. This is a rational function, so step 1, locate the 0 point for denominator. Okay, this will give you the vertical asymptote. We know if we plug in negative 2 here, negative 2 plus 2, you get 0. So 0 point here for denominator is negative 2. X equals negative 2. So that's the vertical asymptote. Okay, so we find out vertical asymptote. Since here numerator, the exponent of numerator is 2, the exponent of denominator is 1, 2 is greater than 1, then we don't have a horizontal asymptote. We only have an oblique asymptote. How to find out? Here is the way. You see, it's basically numerator x squared minus x minus 20 divided by x plus 2. You do division. Okay, details are here. You put x times x, x squared, x times 2, 2x. Top one minus the one below, negative cancel, negative 2x, negative 1x, together negative 3x. Negative 20 moves down. You need negative 3 times x, give you negative 3x. Negative 3 times 2 give you negative 6. Minus the following one, change the sign all to plus. Cancel that. You have negative 20 plus 6, which is negative 14. So I just want to recall it. 106 divided by 8 equals 13. Numerator is 13. And the quotient is 13. Okay. So then you basically, how did we get that? You put 1 here, 8. You have 8. 10 minus 8 is 2. 6 goes down. 3 times 8, 24. 26 minus 24, you have a 2. So you may write 106 equals 8 times 13 plus 2. Divided by 8, cancel this 8. So you have 8 over 2. Similar to this one, 106 equals 8 times 13 plus 2. Here is the same. X squared minus x minus 20 equals x plus 2 times x minus 3 plus negative 14. If you divide both sides by x plus 2, okay, then x plus 2 will cancel each other. The right hand side left over is numerator. So is the quotient right here, quotient. And then here is minus 14 over x plus 2. That's the right hand side. The left hand side is just x squared minus x minus 20 over x plus 2. Okay. So look, it's basically this one is the one here, and is the one can be written in this way. Previously we said, recall, when x goes to infinity, this one goes to 0. That's what we wrote here. X goes to infinity, you have this quantity goes to 0. So x goes to infinity, this big quantity goes to 0. Then you have a x minus 3 left, because this one is close to 0. You don't need to count. So when x approaches infinity, you have a y equals this big one is actually equals x minus 3 without that. So that's y equals x minus 3. That's a line, linear function. And this linear function will be the oblique asymptote, because when x goes to infinity, and then the whole quantity will approach to this line. This y will approach to this x minus 3. Y equals x minus 3. That's the oblique asymptote. Okay, so we got vertical asymptote, we got oblique asymptote. We want to sketch it. How does it look like? If you let x be 0, and then y equals 0 minus 3, 0 minus 3, that's negative 3. So x is 0, y is negative 3. Then you have a 0, negative 3, 0, negative 3 on the line. If you let y be 0, then 0 equals x minus 3, plus 3 on both sides, cancel positive, negative. X equals 3. So x is 3 when y is 0. So you have a 3, 0, this point on the line. You have 2 points, you connect it, that will be the oblique asymptote. So basically you find out oblique asymptote is by division. You can also use the synthetic division. Okay? Right here I use the long division. So after you find out the oblique one, oblique asymptote, you sketch it, find the 2 points like that. So for the rational function, most important thing is that you need to find out vertical asymptote, horizontal asymptote. If we do not have it in this case because of exponent of numerator, the highest one, is greater than the highest degree of denominator. One more than that. Here is 2, here is 1. By long division, you have here this equation is y equals x minus 3 for this dotted line. That's oblique asymptote. So you see vertical one, oblique one, they intercept here. Now